In this video, I want to show you where the product to sum formulas come from. Well, they come from pretty much where all the other formulas come from. They start from the sine of a plus b. Uh, this is like the granddaddy of all of them here. Sine of a plus b, remember, was sine a cos b plus cosine a sine b. Then I had the sine of a minus b, that is replacing b's by negative b's. Replace the b by negative b, but the cosine just absorbs it. The sine of negative b, on the other hand, the sine doesn't absorb the negative sign. It spits it out in front, right? Because cosine is even, sine is odd. So I've got these two identities here. And what I want to do is I just want to add them together. So if I add these two, I've got the sine of a plus b plus the sine of a minus b. And on this side, when I add all of this stuff to all of that stuff, well, I'm going to have a sine of a plus b, sine a cos b and a sine a cos b added together. That would be 2 sine a cos b. And I've got a plus cosine a sine b added to a negative cosine a sine b. So those two go away. And I now have this thing here. We have a product on one side and a sum on the other side. Typically, this is not left like this. It could be, but usually you divide the two over. So, and I'm going to write it this way. I'm going to write the product on this side. So sine a cosine b is equal to, and I divide the two, so 1/2 of this thing, sine of a plus b plus the sine of a minus b. Now this is called a product to sum formula because you start with a product and you end with a sum. You could say no, but you start with a sum and you end with a product. But okay, hang on a minute. On the product side, you have simple angles, a and b. On the sum side, you have more complicated angles, combinations of a and b. So you start with the simple side here, sine a cos b, and you get the more complicated angles here, sine a plus b plus sine a minus b, all times 1/2. That's the first product to sum formula. The second product to sum formula, I'm going to use the same two identities. Okay, so I'm going to use the same two identities as I did before, but rather than adding them, this time I'm going to subtract them. So I have the sine of a plus b minus the sine of a minus b. Okay, so what happens here? Well, when I subtract these sides, so it was the top minus the bottom, so the top stuff minus the bottom stuff. Well, this time I've got a sine a cos b. Now I'm subtracting sine a cos b, so that goes away. I've got a cos a sine b, and I'm subtracting negative cos a sine b. Is that what I said? Cos a sine b, subtracting negative cos a sine b. Those actually add up to be 2 cos a sine b. And so I can do the same thing I did before here, divide by 2. So I've got cos a sine b equals 1/2, the difference here, sine of a plus b minus the sine of a minus b. Okay. Now, one thing I want to point out here is that it looks to me, I remember learning this, that aren't these the same thing? This is just a product of the sine of one thing and the cosine of another. Sine of one thing, cosine of another. Multiplication is commutative, so it doesn't matter which order you multiply them in. Right? But yet one you're adding and the other you're subtracting. So how could that be? Does this really make a difference? And the answer is no, it doesn't make a difference. Notice that this one here is an a minus b, where the a came from the thing with the sine and the b came from the thing with the cosine. Here, this is a minus b, where a comes from the cosine and b with the sine. So they're coming from a different place. You're subtracting in a different order here. And this one has a minus sign out in front. Okay, let me do a quick example here. What is the sine of 2x times the cosine of 6x? Okay, well, according to this one, because it's a sine times cosine, this should be 1/2 the sine of 2x plus 6x plus the sine of 2x minus 6x, which is 1/2 the sine of 8x plus the sine of negative 4x. Right? So that was using the first identity up here. Okay. Now let's try that same problem again, but this time let's just multiply in the other order. So suppose I call this cosine of 6x times the sine of 2x. Now I'm thinking about this identity because I've got the cosine first. So now 6x is playing the role of A and 2x is playing the role of B. So anyway, this would be 1/2. So looking at this identity, sine of 6x plus 2x minus the sine of 6x minus 2x. Right? So this is 1/2 sine of 8x minus the sine of 4x. So where the first time we had plus the sine of negative 4x, now we have minus the sine of plus 4x. And those are equal to each other because sine is odd. That minus sign can go in or out. Right? So these really are very much the same identity, although they're usually listed separately. Sine of A cosine B or cosine A sine B, and you end up with a sum or a difference of two sines. Okay. You may think about times when algebraically you'd much rather have things added than you would multiplied. Right? I got two others that I want to do. This time I want to start with, here we go, the cosine of A plus B. And if, I called the sine of A plus B the granddaddy of all the other identities, well, the cosine of A plus B is the grandmother, because it's used just as often, if not, maybe even more so. So cosine of A plus B is the cosine of A times the cosine of B minus the sine of A times the sine of B. And if I look at the cosine of A minus B, again, it's the same thing as that, only with negative b's plugged in. And the cosine just absorbs the negative sign, because cosine's an even function. But the sine's going to spit the negative sign out to go with the one that's already out in front there, turn that into a plus sign. Okay. And now I'm going to do to these what I did to the ones above. I'm going to add them, and I'm going to subtract them. So let's start by adding them. Let's look at the cosine of A plus B plus the cosine of A minus B. Well, that's equal to this plus that. Well, these two add up to give me two of those. 2 cos A, cos B. And this one, when I add those up, they go away because I got minus that and plus the same thing, so they go away. And now again, I've got a sum turning into 2 times the product. Let's divide by 2. So I've got the cosine of A times the cosine of B equals 1/2 the cosine of A plus B plus the cosine of A minus B. All right. So a product of 2 cosines can be turned into a sum of 2 cosines. Likewise, I'm going to start with these two again, and I'm going to subtract. So I've got the cosine of A plus B minus the cosine of A minus B. So this stuff on top minus that stuff on the bottom. Again, the cosines, no, not again. Before, when we're adding, those two added up. Now when I'm subtracting, they go away. And this time, I've got the minus this, and I'm subtracting this. So actually, I think I end up with negative 2 times the sine of A and the sine of B here. Right? And then when I divide by negative 2 this time, I'm going to have the sine of A times the sine of B equals negative 1/2 times this difference, cosine A plus B minus the cosine of A minus B. Okay, so where a product of cosines turned into a sum of cosines. A product of sines turns into a difference of cosines. Okay. There's the times of minus a half out in front that you could distribute through if you want. You're still ending up with a difference of a couple of things. So there are 4 product of sum identities. Either you're multiplying a cosine times, we'll go up to the top one, a sine times a cosine, which is the sum of 2 sines, or a cosine times a sine, which is the difference of 2 sines. Now you get down here where you've got a product of cosines turning into a sum of cosines, or a product of sines turning into a difference of cosines. Okay. 4 product to sum identities that come straight out of sine of a plus b and cosine of a plus b. You're either adding a couple of these together or you're subtracting them. Okay. There are the product to sum formulas.